Notes about quadratic equations, specifically complex roots. Now that you're in Algebra 2, I think it's time for you to be able to handle the truth about this. Okay, when you were solving quadratic equations, you didn't see one like this. Even though it's very simple. A equal 1, B equal 1, C equal 1. You innocently plug it into the quadratic formula, expecting to get some answers, and you get -1 here, 1 squared minus 4ac over 2a, and something strange happens in here that you don't see before. It comes out a negative in the square root, which is not in the real number system. So what is going on? So before we proceed with what's going on there, consider this simple equation. X squared plus 1 equals 0. Well, that would mean that x squared equals -1, and nothing squared is -1. Well, no real number squared is -1, and that drives mathematicians bonkers. X equals plus or minus a square root of -1. So they couldn't let that stand. So we let the square root of -1 be called the number I. And it is not in the real number system. But what we do with it is we adjoin it to the real number system to create numbers of the form a plus bi, where a and b are real numbers. We create new numbers. These new numbers make up what's called the complex number system. Okay, we won't be studying that in this course, but it's a whole field of mathematics that you learn about in pre-calculus. Okay, let's go back to this now. So back to the square root of -3. The square root of -3 would be the square root of 3 times -1 in there. You can break apart a square root. Square root of 3 times square root of -1, which is the square root of 3i. So the solutions of this equation, this innocent equation, is what we had there, which turned into this, square root of 3i. So square root of -3 was square root of 3i, and then all over 2. So the two roots of the function x squared plus x plus 1 are this one and this one. But these are complex numbers. They are not in the real number system. So what does this mean graphically? Okay, let's go over to this side first. Let's take that function. The roots of that function set equal to 0, as we saw, are this from the quadratic formula. You get this I in there. It means that there are no real number x-intercepts, because these roots are supposed to be the x-intercepts, but they're not real numbers, so they can't be on the x-line. So the graph does not cross the x-axis. Another thing it means is that the b squared minus 4ac part of the quadratic formula, this part in here, that this part here, b squared minus 4ac, is called the discriminant. And it comes out to be a negative number, which we saw right up here. It came out to be a negative number. And that's when the trouble is, and I showed it here too. B squared minus 4ac came out -3. So those are all the telltale signs that your graph does not cross the x-axis. See, you're looking in here for it to cross the x-axis. Here's the x. It doesn't touch it. It misses it. It can miss it by going upward like this, or it can miss it by going down. That's the two ways that it can miss it. So that's what happens with a graph when you have this kind of a situation. the graph does not cross the x-axis, that means that you're going to have complex roots. That means that the b squared minus 4ac part is going to be negative. Those all mean the same thing. Now let's go over here to a nicer case. F of x equals x squared minus 3x minus 4. Now in this case, there are nice roots, 4 and negative 1. You know, when you factor it out, it comes out nice. So there are real number x-intercepts. There are. That means that the graph does cross the x-axis. That means that the b squared minus 4ac part is positive, which it is here. Negative 3 squared minus 4ac, and that comes out to be 25. That's a positive number. And the graph indeed shows that you cross the x-axis in these two roots, which were 4 and negative 1. So it all ties in together. So that's the case. This case is the case we've been seeing. We have not been seeing this complex number case. Now, for the full truth of it, there's one more case. Something like this. When you find the roots of that, it's factors as a squared binomial, x minus 1 times x minus 1. So when you solve this, you get x equals 1 or x equals 1. X equals 1 in this kind of case is called a double root. It's also called, a more sophisticated term for that, it's a root of multiplicity 2. It occurs twice. So what happens in this case with the graph? The graph touches the x-axis only in one point, 1, 0. So what happens with the discriminant? It equals 0 in that case. So check this out. This is how y. So here's the quadratic formula for this function right here. Negative b plus or minus square root of b squared minus 4ac all over 2. And negative 2 squared is 4. And 4 times 1 times 1 is 4. So 4 minus 4 is 0. So that's how this wipes out. And you just get 2 over 2, which is 1. So there's one root of multiplicity 2. And over on the graph, you can see that it just crosses, really just touches it, and goes back up right there at 1. It could also, you could have a situation where it would touch and go down if there was a negative number in front of the parabola. So that's all the three cases. Of course, there is one thing with this type. You could get irrational roots out of this type of thing, and it would still cross the x-axis in two places, though, even if there were irrational roots.